things that are driving the new telescopes. The new telescopes, I'm going to finish just a second here, the new telescopes were pioneered in 1979 by this telescope called the multi-mirror telescope. It's got 6 60-inch mirrors situated around the edge. It was a way to build a lightweight telescope, have lots of area, and lo and behold, if you think about the picture you're seeing, when you point it, you're going to cock the telescope up and down, and you're going to move the building around on wheels. It went back to Herschel's old design. Okay. A few years ago, they took out that structure, they kept the same dome, and they put in a single blank, which had been cast under a football stadium in Arizona. And this was the first of the large single blanks that are going into the new telescopes. And now you see, oops, sorry. Looks like I lost it. No, it'll come later. Let me go ahead. So this is a telescope with an effective area of about 22 meters. And you can see it's just combinations of all the things I showed you. It's a few very, very large mirrors, the 8 meter, 8.5 meter blanks cast together. This is called the Giant Magellan Telescope, which is now gathering partners. It'll probably cost about $1 billion, and it's the next thing to reach into the universe. I want to close with this, going back to this idea of the star images. 1640, we realized that images are blurred by the atmosphere. Everybody tried to get rid of that by making better optics, better polishing, building walls so the wind couldn't get through, letting the wind blow through. I mean, people tried everything you can think of. I've mentioned those. And nowadays, we think that problem is, it's not quite solved, but we're on the way. This is a picture of the 200-inch at Mount Palomar in California. Firing a laser up into the atmosphere, the laser light will bounce back through the atmosphere and allow the disturbances in the atmosphere to be corrected for any stars that are shining right next to it. These are some examples. The picture on the left is an image taken with a normal telescope of a object. I mean, this particular object has just been discovered to be so complex. We get the best image we can. It looks like it's on the left. The one on the right is taken with a new technique called adaptive optics. This is still about it's about 4 times worse than the best that can be done. These images will therefore be comparable to the Hubble telescope, and the telescopes will be bigger by many, many factors. The image on the left, the orange image, is a picture of a globular cluster called M13. This picture could have been made any time between 1670 and 1990. When you were seeing it with your eye, you wouldn't have seen the fainter objects, but once you had photographic plates, it's just the same image for all that time. The picture on the left is taken with a variety of optical techniques, including adaptive optics, and you can see how many more stars you can see and how much smaller they are. A section of the picture on the upper right is shown just below it. You can see all the little points of light. And the picture on the left is the very best that can be done with the Hubble Space Telescope. So we've now exceeded on the ground the quality of what cost over $4 billion to have in space. And so people think that finally, after 400 years, this problem is solved. So you can see there have been a lot of accidents. This is the story is people in the right places, people with a prepared mind, if you will, like Galileo. Unexpected developments that brought improvements in detectors. The photographic plate was purely driven by commercial activity. People wanted to have their picture taken, period. Right. The people who did it were amateurs. They were mostly wealthy and just had time to do good things. And they did it, and they talked to each other and kind of made a little aristocracy of their own, or a stellarocracy, I guess we could call it. The astronomers had to find excellent tradespeople, people who could do machining and so forth. A lot of be wiped out. Newton had his myths about, I told you about refracting optics. The church had its myths about whether the sun went around the earth around the sun. Raleigh had the age of the earth wrong. I showed you that. He was supplanted by Darwin. the Chinese imperial government completely absorbed all astronomy and made it a hobby for their friends, and it had no significance in China. The telescope had no significance at all. Events came out of nowhere that weren't expected and led to discoveries by scientists, sunspots, Halley's Comet, and so forth. Lots of sponsors, patrons, personal or corporate wealth. Recently, the government has been involved. And finally, a society in which asking questions is the right thing to do. The observers can't make claims that aren't challenged by the theoreticians, and the theoreticians can't make claims that aren't tested by the observations. This only developed in the West and not in the East, in China and so forth. Thank you very much.
We have time for a few questions, if anybody has something. If you could raise your hand so I can bring you the mic. Any questions?
There's one back there.
Ah, back there. Thank you.
Did you say you knew the guy who found the first extra planet outside of our solar system?
Yes.
You were going to tell us something about that.
I asked him once why he had data going back to 1990, but he didn't make the discovery till 1994. And it turned out they were looking for something completely different. They were just looking for binary star motions. And once they got a hint that there might be something there, they got out their computers and just squeezed and squeezed and squeezed and finally pulled it out of nowhere. But in principle, the measurement they made could not have been made in the normal ways. This took a computer to make it work. So it was a pure accident, maybe a flash of insight, I don't know, but an accident nonetheless. His name is Jeff Marcy. There's a question. No. Did you have a question?
Anybody else? Okay. In addition to thanking Professor York again, I'd also like to extend our thanks to the Louisville Astronomical Society for their efforts tonight in promoting and assisting with this event. The Society of Physics students here at the University of Louisville, who helped set up and seat people. And also the Mortarboard Society, who helped with putting up many of the promotional materials around campus and the city. So let's thank our speaker and these organizations one more time. Thank you all for coming. We will have refreshments out in the atrium, and we'll have time for questions if you have them. Thank you.
Dr. LaRoche, we also have a telescope manned by the quarter moon.
Okay.